serve as General Chair for this PODS conference, and in that capacity it's my honor to introduce our keynote speaker. But before I do that, I want to again follow up on what Marcelo said and again do a small pitch for the PODS business meeting, which is tonight at 7. So where we will actually have a report on how this program was developed. We will also get insight in the next PODSes, information about what will happen in PODS 2019, PODS 2020, some information how PODS is run, and also important to get some feedback from you and some discussion on PODS in general. So if you feel part of the PODS community, please feel welcome to come to the business meeting. It is at 7. You can find it in your program. It will not take that long, so there will still plenty of time to attend the Sigmod reception afterwards. Okay. So now it's my great pleasure to introduce our PODS keynote speaker, who is Michael Benedikt. So Michael was trained as a logician, so he obtained his PhD in mathematical logic under the guidance of the famous logician Jerome Kiesler. But then afterwards he really became, let's say, a computer scientist. I mean, he became a researcher at Bell Labs, where he was involved in industrial projects as well as academic research on the intersection, on the interplay between logic and computer science. And let's say 15 years ago, Moshe Vardi and some other people wrote a manifesto on the unusual effectiveness of logic in computer science. And actually, Michael is really an exponent of that kind of research on the intersection of logic and computer science. And he has grown out to be one of the absolute leaders in this field. And so today, already for many years, Michael is a professor at Oxford University. And so I'm very happy that Michael is giving the keynote speech today, and he will talk about theorem proving in database systems. So please, let's welcome Michael. Let me put it.
Can you hear me, Houston? Come in, Houston.
Houston, we have a problem.
Just a second. Thanks, Jan. Okay, hopefully this thing will behave. So thanks very much to Jan. I want to explain that I prepared for this keynote by reading all the previous PODS keynote papers. This is only a sample, a fraction of the ones that I slaved over. And what I was looking for is some sort of pattern in the structure of these talks that I could grab hold of and apply to my topic. So here was one pattern that I really, really liked. If you've been to a few of the other PODS keynote talks, this is what you might have seen. They would be structured often, not all, but often they would be structured based on some new topic from data management practice. Like in the 90s, objects, streams, multimedia, and in the 2000s, XML, web services, 2010s, machine learning, the cloud. And the beginning of this talk would be an overview of this new development and something about the challenges it brings from data management practice. And then this would lead, the speaker would argue, have to be careful with this. Maybe I should just do this manually. The speaker would argue that to address these new challenges, we need not just better engineering, we need new abstractions, new models, new theory. And this would lead the talk into its core, which is the work of the speaker and their colleagues. How did they develop this new theory, these new models, these new abstractions to address these challenges? And then there would be a nice transition at some point into validation or impact. How did they take this theory and move it back into practice to validate it? And this gave the talk a nice arc, practice to theory to practice. And this is really my initial idea for how to structure this talk. But then I realized I couldn't do that, and so this talk is going to be completely different. So first of all, I couldn't come up with a a new challenge from data management practice where I would be the right person to present this to you. As Jan has mentioned, I came into databases from computational logic, and a lot of the motivation for my work actually comes from the grand challenge of computational logic, which is about making tools that allow computers to reason symbolically. And of course, I've applied that to data management. This is going to be a database talk, don't worry. But somehow, for honesty, I think the real motivation for a lot of this is connected to computational logic. I should put computational logic and reasoning somehow for transparency in the center of the talk. Secondly, I couldn't find any way to structure this talk around my own work. Of course, there's going to be stuff about my own work, plenty of stuff about my own work, but I was reading all of these old papers and trying to make sense of the long view of the field over the last 30, 40 years, and trying to connect it to what I know from outside of databases in computational logic and other areas of theory. And I realized that's a lot of what I've been doing over the last 4 or 5 years, connections between work in principles of data management, mostly not my work, to work going on outside of databases, not my work. And so this inside-outside business, this is going to be a theme of the talk that replaces my work in the core. And lastly, this ain't going to be no success story about bringing practice back to theory, not my success story, not anyone else's success story. I'll say a little bit why later, but for now, this is like a spoiler alert. This is not a talk that's going to end on a super happy note. So this is going to be a different kind of beast, reflection talk, looking back at a really old topic, applying reasoners to analyze, transform, simplify database queries. One of the oldest topics within principles of data management, one of the most well-studied topics. And the idea is take a step back and say, where are we on this? What are some of the accomplishments? If we keep seeing something that's a motivation, but it's not quite accomplished, let's try to drill down on this and look at why. That's the why in the title. And there's going to be this inside-outside theme that goes throughout the talk. How does the stuff that goes on within databases and reasoning relate to all the stuff, all the developments outside in computational logic? You've been here for about a minute, and you've already found out that you're not going to learn about some exciting new practical development. And it's not going to be principally about my own work. Sometimes it won't even be work that I'm an expert in. You know that it's not going to be some inspiring success story. And let me also get this out of the way. This talk is almost entirely text. There's no word clouds. There's no architecture diagrams. There's no animated graphics. There's not a single picture of another researcher. I'm very proud of this. You look up from your laptop, I can guarantee you, you're not going to see your face. You're not going to be jolted into attention by seeing the face of someone you know. Given all this, why should you stay? Well, for PODS people, I think one of the things I want to pitch is this long view of problems in this area. Maybe you don't often get this in a keynote, and connections with work outside. There's going to be an agenda that's hopefully a strong agenda at the end. Maybe that's a little different. There's going to be a look at community and cultural issues, and maybe that's a little different from what you see in typical keynote talks. I didn't see it in the previous ones. For people in Sigmod, it's a tougher sell. I know that. But what I'm going to promise you all is this long view, it's not going to be so technical. You're not going to be blown away. And this agenda is going to be heavy on comments about implementation experiments. I'm going to try to make sure that if you don't care so much about reasoning, you don't even care about theory, then there'll still be something that can resonate with you. Of course, I know a lot of you are also experts on the reasoning side, on the PODS side. I'm going to go over to you and promise you that even if you're a super expert on this topic, I'm going to try to give you some at least new twist. So you will stay also. So I hope I have you both covered. What both groups might like is this outsider perspective. The canonical outsider I have in mind is a computational logician outside of databases, but I think this perspective might work for other kinds of outsiders, like a PODS person who doesn't do reasoning, a database systems researcher, a space alien. What I'm going for is the alienated perspective on a certain line of work. I'm going to start with the context outside what's going on in computational logic and say what I mean by a reasoner in the title. This is a tool for solving one of the core problems in computational logic. Here's a sentence that I'll use in, okay, it was working so well before, and then there's another of these laser pointers someplace around. Maybe here. And it's another one that doesn't seem to work. Okay, I'll make do. No, it's okay. I mean, she's nodding her head, but what? Okay, this sentence has two conjuncts at the top, which we might call database facts. Joe took CS 101 in 2017. Joe was enrolled as a student in the MSc program. And then it's got two conjuncts which we might call database integrity constraints. If someone took a course on some date and that someone was enrolled as an MSc student, then there had to be a postdoc that assisted in the course. If someone number one took a course and someone number two assisted on that course, then someone number one must have been taught by someone number two. One of the core problems is satisfiability. Is a sentence like this, is there some interpretation of student took postdoc assist that makes it true? And it's easy to see that this example is satisfiable. I can make a database that makes it true. And the validity problem is another core problem. Is it the case that under any interpretation of took, student, postdoc, etc., this is true? And it's pretty easy to see that this sentence is not valid. It's easy to come up with a database where it's false. Are two such sentences logically equivalent? One holds exactly when the other holds. Does this sentence entail another sentence? This sentence entails some things about Joe, like Joe was taught by a postdoc. Many of you know these problems, and you'll know from early on the work of Turing, among others. They were shown to be undecidable for first-order logic, the logic with these universal and existential quantifiers and the Boolean connectives, and even for many natural subsets of first-order logic. So the context of computational logic over the decades since Turing's work has been responses to this undecidability. One high-level response is to restrict the logic. First-order logic is too strong, so we could go with propositional logic, like in the first example. That gets us decidability. That's what SAT solvers do. We could also put in a little first-order expressiveness. That's, among other things, SMT solvers do this. This is an example where I have a logical formula with less than. And it should satisfy, I'm looking for a satisfying assignment where less than satisfies the axioms of an inequality, like transitivity. So this is related to database built-ins. So if I choose my theory nicely, like less than, maybe less than plus some arithmetic, then this will be decidable. And this is what SMT solvers do. A third high-level example of this restriction of the logic is description logic reasoners. These would work on something like an entity relationship schema, a graph schema. I'll also call it an arity 2 schema, unary and binary relations. They would deal with entailment problems like this one. And there's many flavors of these description logics, but if you choose your description logic dialect correctly, then they become decidable as well. A second high-level response is to stick with an undecidable logic like first-order logic, but give up termination or completeness. That's what automated theorem provers for first-order logic do. And a last high-level response is put a human in the loop. Allow a human to structure the process of looking for a proof that witnesses validity. That's what interactive theorem provers do. So there's been huge growth in all of these responses over the last decades, and I want to emphasize that this growth has not just been theory, it's been end-to-end. There have been reference implementations, and by that I mean open source software that has a decent user community. People can really build on this, really like a platform. Benchmarking methodology, standards, competitions, bridging the gap to applications. These have all been taken very seriously by these communities. I've been working with these tools over the last 5-6 years, and I want to give you at least a little bit of a quick examples of this. All of these communities have done a fantastic job in making open source tools, and many of these at this point have a really large community of users. standards. There's standards for everything. For SAT solving, there's a standard format for the input formulas. And then also, if an input formula is valid, then there's a proof that witnesses this, and there's a standard format for these proofs. Let's see. Oops. Well, oh, benchmarks. They all have benchmarks. They all have a spirit of competition. One thing I'd like to mention that you might want to look at is the CASC competition in automated theorem proving. This is a massive competition that's run annually with a huge number of tracks. I think it can stand up to even very high standards within databases for benchmarking methodology, the breadth and the depth of the benchmark. SMT comp is another example that's also at a very high level. This is the context outside. And now I want to move inside. And the way I'm going to structure the inside move is as a thought exercise. Imagine you're in a computer science department, and in your department there's a lot of clever people who work on this other stuff. SAT solving, SMT solving. It's postdocs, faculty, even undergrads are doing lots of projects on this. And you would like to recruit them to the dark side. You want to get them to work on using their reasoning skills for database-related problems, like for analyzing and transforming queries. And I want to talk through what your pitch might be to these people. So I think the first thing you want to go to town in bragging about is that we have a great repository of challenge questions for a computational logician. And I really believe this. One just basic example is equivalence of queries. We have 2 queries in some database language. We want to know if they agree on all inputs. And so you could motivate this by an example from a database course you gave. You gave the students an English language query over the TPCH schema, and you asked them to translate it into SQL. You had in mind a model answer in SQL, and all I have to do is move. Now I'm going to try not to move. You had in mind a model answer. Some of them gave another answer that you thought was correct. Some of them gave a model answer that you thought was incorrect. You'd like to be able to check this automatically. This is a super natural, super easy problem to motivate for a computational logician. It's really different from the kind of benchmarks you see in CASC, which are mostly based on mathematics. This is ordinary human beings, students, who are writing logical formulas about the real world. You don't see this very often outside of database query language. It's very intriguing. What am I going to do about this? Okay, here's a variation. Query equivalence with respect to constraints. Here I got 2 queries, a set of integrity constraints. And I want to know if the queries agree on all inputs that satisfy these semantic restrictions. So here's the same example from before over TPCH, but I'm looking for the keys of the customers. And so I have the variation of this example from last time in SQL. And I can realize that since customer key is in orders, I could drop the join on customers completely, and I get an equivalent query. It's not equivalent over every input database, but it's equivalent over TPCH because there's a referential constraint from orders to customer. Okay. Let me try standing completely still. How can I stop it from being on a timer? What? Yeah.
Do it in another way, like we just need to.
If I just go into slideshow mode, it should be not on a timer?
Yeah, so I think you clicked the wrong thing. I think this is still the timer.
Okay, excuse me.
Yeah. Thank you, Molam. Thank you very much. John didn't say I was an expert in PowerPoint. I want to make this clear. So here's a different kind of challenge question, query simplification. I've got a query, and it's in some database language, but it uses some construct that I'm not so happy about, like a correlated subquery. And I'd like to rewrite it to get rid of the correlated subquery, to get rid of this undesirable feature, maybe relative to a set of integrity constraints, like in the last example. Here's the example from the previous slide. It's got a not-exist subquery. And let's assume that a constraint that's not part of TPCH, that every order has exactly one line item. Relative to this constraint, I can rewrite the query as just a join query, getting rid of the correlated subquery. This is an extremely natural problem, an intriguing problem for a computational logician. It's not making the formula smaller. It's not getting rid of some redundant feature. It's getting rid of some construct that's unpleasant. In our case, unpleasant for database runtime. But they can imagine other kinds of situations, other kinds of applications, or for further reasoning, where you'd like to do a pre-processing step to get rid of some construct. I think it's really easy to sell to our would-be recruit. Rewriting over a set of views. This is a problem most people here know about. I have a query, a set of views, and view definitions. I want to get a query that's equivalent to my original query using the views. Here's the same example from a couple slides ago. Here's a couple views. And this query can be rewritten over the views. This is, I think, a little bit of an interesting example, and I'd like to come back to it because of the role of the correlated subquery in it. I just want to make a point now that it's very easy to sell to this computational logician. It's about definitions, which is a core feature of theorem-proving environments. It's about taking a formula. I've got a bunch of definitions, and I want to re-express my formula using these definitions, maybe as a pre-processing step in matching some lemma. Synthesis over an API is related to the view problem. I've got a query, and now I've got some data API for doing lookups. And I want to get a physical plan for my query that's equivalent, maybe relative to these integrity constraints. Here's the same example from before on the left. And here's a data API. I've got a function for doing lookups on customers, returning all the customers. I've got a function call that takes an order key as input and returns all the matching orders. In TPCH, there'll be at most one of these because order key is a key in orders. I've got a function call taking a part key, supplier key, and order key, returning a list of matching line items. Again, in TPCH, there'll be at most one of these. And magically, actually, this query does have a plan in this data API. You don't have to worry about the concrete syntax of this plan language. It comes from a system that I work on, but there's other kinds of languages for this. It's got commands for doing one of these lookups that doesn't have an argument and putting the results in a temporary table. It's got commands for about 5 lines down, taking a bunch of values from temporary tables, putting them into one of these function calls that requires arguments, taking all the results out, and putting them into a temporary table. And then it's got commands for manipulating temporary tables in relational algebra. In the system that's associated with this, these are actually web service calls, and these last kind of commands are things done in middleware to manipulate the outputs of the web service calls. I think it's a very evocative example for a computational logician. It relates, at least will evoke, something like the Curry-Howard isomorphism, which is an important result about translating from a logic to functional programs. Lots of other examples, lots of things to sell here. In these examples I gave, I used queries from the relational core of SQL, but these problems all make sense when you have aggregation, when you have recursion. There's many other simplification rewriting problems that have been studied. The rewriting data log to remove recursion, the so-called boundedness problem. Rewriting queries to remove joins in favor of semi-joins, the acyclicity rewriting problem. Very easy to argue that we have a great repertoire of challenge questions for computational logicians. When you're done boasting about this, you should really go to town bragging about our techniques. And if your would-be recruit is of a certain age with a certain pop culture taste, you could structure this as a Letterman-style top 10 countdown of your favorite techniques. I've only got 75 minutes for this talk, so I can't do that. So I'm going to do a Letterman Light top 3 countdown of my favorite techniques. To start, I want to go back to these responses to undecidability and note what's kind of a gap there. These SAT solvers and SMT solvers, these are really powerful, but they have very limited support for quantification. This is a recognized problem in the area. And so this example with not exists that has actually a quantifier alternation in it. So that's problematic for them. Equivalence with respect to constraints has at least a universal quantification and usually a quantifier alternation in it. So again, that's a problem. Description logic reasoners have good support for quantifier alternation in many dialects, but we're interested in relational databases, arbitrary number of attributes, arbitrary arity, and they're dealing, or at least focused on graph schemas only. These other approaches give up full automation or completeness or termination. So the gap here is for reasoning with arbitrary relational structures supporting quantification fully, in a fully automated, complete, terminating way. And that's where there's been a lot of great work coming from data management. Which brings me to number 3. It's about reducing reasoning over relations to reasoning about trees. The idea here is we're going to code some complicated labeled graph, some complicated relational structure, in this example, a labeled graph, by a labeled tree. And the idea of this coding is we're going to pick a number like 3, and we're going to say, at most 3 elements of my relational structure, my labeled graph, are going to be represented in the same vertex of a tree. So in this example, imaginary laser pointer here, this lower left vertex is standing in for those 3 vertices, so there's 3 elements on the left of my labeled graph. And this vertex here on the right, it's standing in for the green, blue, and yellow elements in the labeled graph on the left. Top vertex of the tree standing in for those top 3 elements. And I'm going to label each vertex of my tree by the isomorphism type of the elements it's standing into for. So this vertex here on the left in the tree, it's labeled with the isomorphism type of the corresponding red, orange, and green elements. I have additional labels, additional annotations, these numbers, and they're going to tell me how to glue together these local isomorphism types to get back a large isomorphism type of a labeled graph. So the key thing in this number scheme is I use the same number 3 for the adjacent versions of this green element, the adjacent copies of this. And that tells me that to glue together these local isomorphism types, I identify these 3 different versions of the green element. And that gets me back the labeled graph that I'm interested in. This is a natural coding scheme for mapping an arbitrary labeled graph to a tree. How does it help us? Well, we can now translate queries over labeled graphs to queries over trees. If I have a query that says I'm looking for 2 red nodes connected to a green node in the labeled graph, then I can translate that to, well, many different patterns that I have to look for in the tree. I should look for this pattern here on the right, because this, under my coding scheme, I would identify the 2 versions of the green element, and that means I have a green node connected to 2 red nodes in the corresponding decoded structure. But I also have to look for this pattern in the labeled tree, because under our coding schema, this will also imply that I've got 2 red nodes connected to a green node. I've got a lot of different patterns that I have to look for. But I can summarize all of these patterns in a single computing device, a tree automaton, that's something like a finite automaton over words, but running over trees. So I can generate a tree automaton that runs over a tree and checks whether it's a coding of a structure satisfying phi. And this is a step towards reducing satisfiability for phi to checking whether a phi, this tree automaton, is satisfiable. That is, does it accept some tree? And I can solve this using standard automaton tricks. I mean, it's roughly analogous to checking whether a finite state word automata accepts some word, which you can do using a reachability analysis. For this kind of tree automaton that I need here, it's more complicated, but it's the same idea. Now, there's a hitch here having to do with this abstraction capacity of the tree vertices. I had to commit that I was going to have at most 3 elements of my labeled graph mapped to 1 vertex of the tree. And once I make this commitment, which I have to make to form the tree automaton, then I can no longer code an arbitrary labeled graph as one of these trees. I can't code a 4-click, for instance. I can only code things with low tree width. So this is a problem, but for formulas in a restricted logic, I can show that if there's going to be any satisfying labeled graph, then there'll be one that's represented by a tree with this low number of elements per vertex. This is called the tree-like model property. So many restriction logics have been shown to have it. And if I am in a logic that has the tree-like model property, I can carry out this program, translating a formula over relational structures to a tree automaton running over the trees. And then to check whether phi is satisfiable, I check whether the automaton accepts some tree, can do that using standard tricks from automata. I know that these two things are equivalent using the tree-like model property. A similar reduction works for the other core computational logic problems, validity, equivalence, entailment. Many of you are really, really familiar with this technique. Some of you may have helped invent this technique. It's not my technique, I told you. Many of you might say, well, we can't brag about this because this is a technique coming from computational logic. And indeed, it has a fascinating history. It originated in work in description logic, modal logic. People like Van Bentham, Vardy, Clark, Emerson. It was developed in finite model theory in the 90s and early 2000s by Gradle, Otto, and others. But I'm going to claim, and I think you should claim in the recruiting pitch, that it's a database technique now. First of all, database research was involved very early on. In the very first PODS, there's a seminal paper by Johnson and Klug that basically independently rediscovered this technique and applied it to a database problem, query containment with referential constraints. Not so long later on, it was used for containment of data log. That's a database language by Chiduri and Vardy. It was used, variations of it were used for regular path query problems by database people. In the mid-2000s, there was an important development coming from Geert Gottlob and his collaborators. They showed how to connect the work of Johnson and Klug in databases with work outside of Gradle, Otto, Van Bentham. And they also showed how to get many, many more applications within data management. And since that work, there's been a steady stream of papers on this topic. Actually, most of the papers on this topic are in database venues. Up to the current PODS, there's at least one paper that I know of, Barcelo, Berger, and Piras, developing this technique later this week in PODS. I want to give you an example of the method, a really obscure example, to show you how many papers I've read. It's from a VLDB paper by Barani, Tenkate, and Otto. They look at relational algebra, and they make one restriction to relational algebra. They restrict the difference operator so that you can only subtract off from the projection of a relation. You can use difference to filter out tuples, but you can't filter out from a join. You can only filter out from stuff that's sitting in a single relation. This is called guarded negation relational algebra. And they show that if you make this one restriction, all the basic computational problems become decidable. This is actually a corollary of an earlier result of Barani, Tenkate, and Sagofan. This is the tip of the iceberg of the kind of applications this has in databases. It's a very versatile technique. Equivalence and containment with constraints. It can be used for equivalence problems involving data log, solving some of these simplification problems, the boundedness problem that I mentioned before, and this acyclicity rewriting problem. This technique can be used for those problems as well. And that's why I think we're in very good shape in selling it as our number 3. Number 2. A warm-up first. Go back to these rewriting and simplification problems. I'll give an abstract version of this. I have a query and some target language and a set of integrity constraints. I want another query equivalent to my original query that's in the target language. I'll leave this target language vague, but you can think it could be either restricting the kind of tables that I could use, like in the view rewriting problem, or the kind of operators that I use, like in avoiding correlated subqueries. The thing to note about this is that it's not one of the core computational logic problems that people in these other fields outside work on. And so there's a big question, how can I apply those people's tools to solve this problem? And that brings us to number 2, reducing rewriting to theorem proving, which is doing exactly that. We have a technique for, given a rewriting problem, coming up with an entailment problem. Does phi entail psi, such that the rewriting problem has a solution exactly when the entailment holds, that is, exactly when phi does prove psi. I'm going to give you a flavor of this technique. It's going to be a little bit artificial. Suppose you have a query in some database language like relational algebra, and it's got negation, a correlated subquery, something like that in it, but you're suspicious that this use of negation of this complicated construct is junk. And you'd like to see if you could get rid of it. Rewrite the query to be a union of conjunctive queries or a union select project join query in relational algebra. Here, the target language is the UCQ queries. So what you can observe is that if it's going to be rewritable to a union of conjunctive queries, that it better be monotone. As I add more data, I get more examples, because UCQs, union select project join queries, have that property. So what I can do is say, first, I'm going to try and prove that Q is monotone. That is, if I have two query inputs, I1 and I2, where I1 is contained in I2, then the output of Q on I1 is contained in the output of Q on I2. That's monotonicity. And I can write a sentence that says the data of I1 is contained in the data of I2. To write this sentence, I need 2 copies of the signature for every relation, every table. I need a R1 and an R2, and I'll say for all x, R1x implies R2x. I can write a first-order logic sentence that says, for all my relations, all my tables, one copy is contained in the other copy. I can write another sentence that says output of Q on I1 is contained in the output of Q on I2. Again, I need 2 copies of the signature for that. And now Q is monotone exactly when there's a proof of psi Q from phi. That's just unwinding the definitions. But from a proof of psi Q from phi, I can read off a UCQ rewriting. And this is actually an old technique from logic. There are polynomial time algorithms for doing this called interpolation algorithms. They would be well known to our would-be recruit in computational logic. I've found over the last 5 years I've been working on this technique, it's extremely powerful. You can use it to solve that challenge question about removing correlated subqueries. You can use it for view rewriting problems, many kind of view rewriting problems. This technique out of the box works for them. This plan generation problem, plan synthesis with a data API, you can use this technique to solve that problem. Of course, it's not my technique. And you could argue we shouldn't brag about it because actually it comes from the work of a logician and philosopher, William Craig, in the 1950s. But of course, now I'm going to say that we can brag about it. It is our technique. If you look at a lot of the classic work in rewriting using views coming from databases, the classic results of Levy, Mendelssohn, Sagiv, Srivastava, the chase and batch chase of Deutsch, Popa, and Tannen, a lot of the techniques that are summarized in the book of Afrati and Cherkova, you can see them as instances of this technique. Of course, these guys are adding on lots of algorithmic tricks to get better efficiency. They're not applying this technique out of the box. But you can see what they're doing as special cases of this reduction. This reduction was first sort of brought to the fore in a test of time paper from PODS 2005 by Segoffin and Vianu, and accompanying Todd's paper of Nash, Segoffin, and Vianu. The algorithmic implications were developed by Thoman and Waddell first in a Morgan Claypool synthesis data lectures book. A variant of this reduction for synthesizing plans, this stems from an ICDT paper of Deutsch, Luderscher, and Nash. And since this ICDT paper, there's been a steady stream of papers in database venues on this technique. We're on solid ground in claiming it's our number 2 at this point. Number 1. Suspense. Anticlimax, total anticlimax. I've grouped together all of the work done in the community on conjunctive queries and dependencies and made that into a single technique and said it's number 1. It's a little cheap. What is this? It's the same problem I started with in this talk. I've got some database facts, maybe a large collection of facts. I've got some dependencies, and I want to know if that entails some conjunctive query like Joe was taught by a postdoc. There's a huge toolkit that has been developed for deciding this problem. It's been a big accomplishment in reasoning of this community. But I think it's interesting to describe exactly how we're going to brag about it to a computational logician, how we're going to describe it. I think one of the things you can say is that we have some bog standard reasoning techniques, like moving forward from the facts with the constraints, moving backward from the queries using the constraints. These are actually standard reasoning steps related to resolution. But what we've done is we've identified syntactic conditions which will tell us, in this situation, you should use the forward reasoning technique, and you know it will terminate. In this situation, you should use the backward reasoning technique because it's guaranteed to terminate. And I think this will be immediately very evocative for a computational logician. They would immediately think, how could these techniques be integrated into a theorem-proving environment? Because that's a lot about what modern theorem-proving environments like Lean, that I mentioned was briefly on the slide, are about. A second thing they've done is identified further syntactic restrictions that guarantee that these techniques are scalable when I fix the constraints and the queries, and I just make the set of facts become big. Conditions that will allow me to guarantee that the inference is polynomial in the number of facts. And there's some corresponding algorithms that, in these cases, will implement the inference scalably on top of a DBMS. Again, I think this is very evocative for a computational logician about how these can be integrated into a theorem-proving environment. This is closely related to the chase, which is the topic of one of the test of time, Gems of PODS talks that Marcelo mentioned. And that's going to be my excuse for not saying anything more about it. You'll hear much about this later this morning. I want to say a little bit about how the challenge problems and techniques match up. I can say more from some of the work I've done later on, but a short version of it is it's not so bad. If I look at this equivalence of queries problem, you could solve this using the reduction to tree reasoning. Of course, you need a translation of SQL to logic, but a standard translation will do. And you need to be a little careful about this inequality. Inequalities are satisfying special axioms like transitivity, and transitivity is actually quite problematic for this tree-like model property. However, here it's inequality with a constant, which is actually not so bad. You can use some pre-processing steps to reclaim the tree-like model property. Equivalence with respect to constraints, similarly, with the same caveats, you can use the reduction to tree reasoning. Rewriting over a set of views, you can hit it first with the reduction to theorem proving. You get an entailment problem that you can stick into a reasoner. If you want to, actually, this theorem proving problem, you can solve with the reduction to tree reasoning. You can combine these two techniques. Synthesis over a data API, same story. You can apply the reduction to theorem proving, you'll get a problem that's a standard problem for a theorem prover. And then you can apply, if you want, the reduction to tree reasoning to solve that problem, decidedly. So I've done a little bit of cherry picking here of the examples, and I'll come back to be more honest in a few slides. But the short story of this is these techniques are super powerful. Okay, they're very powerful. And you can solve a lot of our challenge problems with these techniques. Let's remember we're in a thought experiment here with your colleague in your department. And how's it going? It's going well. They've got a fairly mature set of tools which intuitively should be of great use to data management. And what we've got is a host of interesting challenge problems. We've got our own reasoning techniques to brag about that fill some gaps. And we've developed reductions from our problems to their problems. It's a fantastic opportunity to link these efforts outside and inside. And it's all going super well until our recruitment asks us the fatal question. I'm dying to get going. Where should I start? Show me the infrastructure. Now remember, they're used to a lot of infrastructure, serious infrastructure. That was part of the good news. They're used to these reference implementations with decent user communities, benchmarks, standards, competitions. Now there's something I have to tell you about this talk. This is a part of the talk that I've struggled with a lot. It's the part where I say some negative stuff about infrastructure. This is dangerous for a number of reasons. First of all, it's hard to say that there aren't tools of certain kinds in any area. I mean, it's dangerous. First of all, I've done my homework here. I've spent a huge amount of time sending emails to people who wrote a paper about certain tools with experiments, asking to get the software. I mean, I really worked on this for years and years and years. But of course, I might have missed some tool. Web is a big place. And when am I most likely to find about some tool I missed? It would be during my keynote talk. There's also danger related to the tools that I have found. Many of these, I feel that nobody could use except maybe the authors. We've spent a lot of time in my group trying to see what these tools can really do. But of course, these tools, they've been developed by serious scientists. I've also been in the same situation before. These are people I respect. Sometimes they're even my friends. I think as scientists, they might expect that I would mention their tools in this talk. But on the other hand, if I mention these tools, all of them, then it gives the impression of a lot of infrastructure. The next person down the line is in the same situation that my group has been in for 4 or 5 years, spending all their time sending these emails, looking around. So this has been a huge dilemma for me that I'd like to discuss. And I'm going to tell you how I'm going to play it. I'm going to propose a test, an objective test, I claim, for whether there are reference implementations. You can take this as the definition of a reference implementation. It's inspired by life outside, where you don't have to spend so much time sending emails. And maybe it will help you, maybe the only thing from this talk that might help you if you're in a similar situation. I call it the Google test. What you do is you take the keywords from the area and you add the words software download, you put them into Google, and if it 3 clicks, you can get to source code. That's a reference implementation. Okay, it's stupid. It's not perfect. But let's check it out. SMT solver software download, bingo. CVC4, etc. Interactive theorem proving download software, hello, HOL, hello, Coke, hello, Y3, Matita. I don't even know what those are, but they are interactive theorem provers. There is source code for each of them. It's looking fine. How about view rewriting software download, essay rewriter? It's not going to help us. How about query rewriting using views download software, PDFs, videos? Okay, you can start fiddling with these keywords, but at a certain point, if you start fiddling too much, you're not in the spirit of the Google test. All of this stuff that I just gave you, it was meant to justify this slide, saying there's no reference implementations around these simplification and rewriting problems, none. I have a system that I've worked on related to that language, but it doesn't pass the Google test, and it has terrible documentation, terrible usability right now. We're working on a new version, and I'm hoping that in 3 months I could pass the Google test, but right now I can't claim that my software is any different. I won't talk about standardized syntax for inputs at the moment, but benchmarks and competition, certainly there's nothing here. How about fully automated terminating checkers for database queries, like these decidable fragments of relational algebra, decidable fragments of data log? Actually, this is something that's been around for 30 years, say, in the database literature. There's no reference implementation. I don't think there's any implementation at all around. Benchmarks and competition, none. How about testing equivalence of queries, but not fully automated, maybe incomplete, non-terminating? Well, there's something I should mention, a work of Alvin Chung and his collaborators at Washington. There's like Sumo Chu, Dan Sushu, and others. They have a tool called Cassette, which is very interesting. I don't know if I would call it a reference implementation. It's a prototype that's being rewritten to use a different theorem proving technique right now. I'm hoping eventually it will be, but what I can tell you is if this ain't a reference implementation, then there aren't any others. That's all there is. How about benchmark competition? None. How about reasoning with dependencies and CQs? This is the most studied problem in PODS and ICDT ever. What is there? Well, I should mention that there is something nice for the chase. It doesn't have many users at this point, but Lunatic is an open source tool from Geertz, Mecca, Papati, Centura, and Veltri that's nice. There's something else nice that many of you may not know about, the Growl toolkit from a group in Montpellier. It doesn't have everything you would like for reasoning with dependencies and CQs, but it's very nice and it's very well documented. Benchmarking competition, well, I was involved in one in the last year's PODS. What we did was we took every chase implementation that we could get our hands on, and then we compiled all the examples that we could find in like previous papers. And then we looked at running these engines and looking a little bit at benchmarking methodology, like how do you compare a main memory engine with a database-backed engine? And I thought this was nice. I have to admit, though, it's extremely limited. These were all synthetic. And this methodology that we looked at, these methodological questions, it's extremely primitive when you compare to the spec for competing in, say, the CAS competition or the SMT competition. My hope is that this will gain some momentum. People will begin to send me other examples of constraints and queries. Hasn't happened yet, but I still have hopes for this. That's where we are on this. Okay, let's finish with this thought exercise. It's actually not a thought exercise at all. It's based on a true story, many true stories. It doesn't end well. There's a fantastic opportunity here. It's easy to make this case. But the state of platforms, benchmarks, support for evaluation, this is a huge obstacle when you think about the other areas that these people are working in, what they have access to. And I'd say it's also, I mean, a bit, maybe I can say the word embarrassing, given the length of time these problems have been studied compared to the length of time SMT solving has been around, for instance, or some of these other areas have been around. I think it's really time to do something about it. I want to get now to the part about why haven't they done it yet, because I think drilling down is really important. And I think the first thing that has to be said about why things are the way they are is that there's some serious technical challenges here that I've glossed over in the previous part of the talk. And it's important to mention these. For the reduction of relational reasoning to tree reasoning, there's a big hitch here. We're interested in arbitrary relational data, high arity. But as the arity gets bigger, the number of elements that we're going to have to abstract into a single vertex grows also. And if you remember, the label set of these trees is the isomorphism types of this number of elements. So it grows exponentially as this arity grows. So this is a huge problem. You can't even form this tree automaton if you do it in a straightforward way. And this is exactly why the description logic case, which is arity 2, developed more quickly. It's I think, quite natural. I think there can be some ways around it, but for now I'll just note this is a serious technical obstacle. In this reduction of rewriting to theorem proving, there was also a hitch. If you're interested in a single rewriting, it works fine. You can send this entailment problem to a theorem prover, you can get back a proof and put it into an interpolation algorithm, get a rewriting. But for many of the applications I mentioned, what we want is not just a single rewriting. We would like to explore the set of rewritings. Like if you're doing query optimization, you would like to explore the set of rewritings from a query like we do in join exploration. And here we have a problem because now we would like an API for getting many proofs from a theorem prover. We would like to say, get me the next proof, get me the next proof. These APIs don't exist. And for many theorem proving styles, it's not clear how you would re-architect a theorem prover to support this kind of API. Again, I think there can be some ways around it. I don't know that it's a showstopper, but it's a serious obstacle. Okay, the elephant in the room of challenges is going beyond first order. I gave all these examples from the relational core. I said that these techniques, these problems all make sense when you have aggregation or recursion. But handling query equivalence with aggregates, this I think is a huge open issue. This is one of the big problems that Alvin Chung, Dan Sushu, collaborators at Washington have been working on. I'm hoping they'll make progress on it. But obviously it's a very challenging problem. This handling of reduction of view rewriting synthesis problems to theorem proving, it works well for first order queries, relational calculus, relational algebra. But for queries with aggregation, it doesn't work. For queries with recursion, it doesn't work for data log. I think it can be made to work for some of these decidable fragments of data log, but there's still a lot of work to be done there. It's still an open question. For aggregation, view rewriting with aggregates, of course, there's been a lot of work on in the database community, Efrate, Cherkova, Sarah Cohen. But they're not going via some general reduction to theorem proving. So what remains to be seen here is there approach to view rewriting with aggregation, which is an important problem that really can exploit the developments in reasoning. I've got to tell you something else about this talk. There's been a large number of versions, editions of this talk. I've rewritten it a dozen times. And in some versions, there was really a focus on these technical challenges. The structure of the talk was, there was this overview of database-related reasoning problems and techniques, developments outside in computational logic, looking at these developments from three lights. One as a huge opportunity, another as a big motivation, a mandate that we really have to revisit our old questions in light of these developments. And the third thing is a model of what communities that are not so huge and that have origins in theory can do in building infrastructure. I think it's very inspirational in that sense. And then there were these technical challenges around seizing the opportunity. And there was a lot more technical challenges around benchmarking. There's a lot of interesting technical challenges also about how we can generate, for instance, synthetic examples that are hard for a reasoner in our areas. And then there was an exploration of the solution space. And I thought this was a nice structure. It was actually inspired by a previous keynote of Leonid Lipkin's about a few years ago, where you had this structure, great opportunity, problem, exploration of solution space. But in the end, I wasn't satisfied with this structure. It was clear to me that these technical challenges couldn't be the full reason why they haven't done it yet. Because if that had been the case, you would have seen in all these papers a lot of emphasis on these technical challenges, and you would have seen people chipping away at proposing solutions. Here, let's try this. And you don't see anything like that if you look at the literature in this topic. And so I thought there has to be something deeper going on. I should try to dig a little deeper, even if it means returning to the danger zone. So now I'm going to go double down a little bit and speak a little bit about some cultural challenges that might have something to do with this. Well, I mean, one thing that I think is worth exploring is issues around goals, commitment, and mission. Who is this they who should have done it but didn't do it? Who really owns this issue about creating infrastructure? There's people at the application level, like people who work on, let's say, data warehousing, who care about views, or people working on query optimization, unlikely to say they owned this. People in computational logic maybe someday, but people in computational logic and theorem proving, probably not that community. For PODS, there's an obvious issue that this is a theory community, not usually the kind of thing associated with building infrastructure. But there's a different issue that I want to mention, which is principles of data management. It's a big topic, and it's not a big community. And so if you look at the names of people I mentioned before working on these reasoning problems, you'll see that they worked on lots and lots of other topics. And this is intrinsic to the nature of the beast. Big topic, not a huge community, so you have to move around. And principles of data management is also a very dynamic topic. If you go back to that very first slide, in the 90s, objects. In the 2000s, early 2000s, XML. Late 2000s, uncertain data. 2010s, machine learning, the cloud. Databases is always changing dramatically. And principles of data management has to realign itself to be in sync with what is the main challenges that data management wants people to look at. This is very different from these other communities that I mentioned. Interactive theorem proving I followed for decades. They've worked on interactive theorem proving and interactive theorem proving, followed by a little bit of interactive theorem proving. And who owns the problem about making interactive theorem proving happen? It's the interactive theorem proving community. Who owns the problem of making description logic infrastructure happening? It's the description logic community. It's very clear. Of course, I'm not saying that there's something wrong that we should change, and people in principles of data management should be spending 30 years looking at these problems. That would be ridiculous. I'm just saying this is a difference, a cultural community difference, and we have to be keeping this in mind. It has something to do, I think, with why haven't they done it. A second kind of high-level issue revolves around decay in transparency. So if you think about a pure theory topic, as decades go by, it becomes easier to understand this topic. You can't read the paper from 30 years ago, but it doesn't matter because the newer paper has a stronger theorem, better notation, cleaner proof, more general result. Same thing if you have something that's super applied, there's lots of systems available, then in the worst case, you just run the systems and you see what tools can and can't do. But what about a topic that's straddling theory and practice, one which there's a steady stream of systems, but none of them are hanging around for so long? There's a danger of getting into a different dynamic where transparency, where it becomes harder to understand what's going on as time goes by, and you have to fight against this. So one of the things that becomes difficult is deciding what developments are really aligned with current database systems and which are more speculative, more sort of puzzles, for instance. For example, at a certain point, someone introduces a problem, and then they say this is the fundamental computational problem for query optimization, a very practical problem. Maybe this is bag containment or query containment with constraints. And there's some decoding that you naturally have to do. Is this really a problem that database systems are working on today? Is this something that if we had a solution for, we would immediately know how to put it into an architecture? Or maybe this is something more speculative. Maybe it's even more of a technical challenge or a puzzle. When these problems are proposed, there's a nuanced understanding of where they sit. But as time goes on, what you see is people just reference fundamental problem, paper after paper. New people come into the community, and they don't have a nuanced view of where these things sit between theory and practice. Some of them think this is a super important problem. Some of them think it's a puzzle. You know, you get all sorts of violently opposing positions on this, and all of them think that, oh, this is the standard position. Transparency decays over time. In the absence of systems, you can also get a different kind of transparency decay. As I think all of you had the experience that if you're in an area where there aren't so many systems that you can touch and feel, writing the related work becomes an agony. What are you going to say about all these tools that you've read about in the past? Probably what you're going to do is be very diplomatic, be very generous, say, oh, they solved all the problems that they were working on, but our problem is slightly different. And in paper after paper, these positive comments are pushed down year after year after year. People begin to believe them. People who don't believe them, of course, at a certain point, they can't say otherwise. They can't get up in front of a big audience and say that these problems are not solved. That would be crazy. Okay, I think maybe you get the flavor of these cultural challenges. I want to give you an agenda for tackling both, well, the technical challenges and the cultural challenges. Stuff that I'm working on, but also other people in the community are working on them. But I think it needs to get more of a higher profile and be a community effort. So one of them is in the category of platforms. Developing and strengthening implementations, for instance, of the 3 techniques I mentioned before. In the case of things related to the chase, it's about integration with theorem proving. That's what I'm looking at. For the other 2 techniques, it's handling these 2 challenges technical challenges that I mentioned. And I think the goal here is to get something like Minibase for database-related reasoning problems. Not the bestest, the fastest tool, but something people can really learn from, a platform that people can really build on. That's really a key thing that's missing here. Looking at bridging the gap between general SQL queries and logics for which we have interesting algorithms. This is not something that I'm looking on, but this is very much in line of the stuff that Alvin Chung and collaborators at Washington are looking at. But I think there's room for a lot of people to get involved here. Support for open competition. I'm working on this, but really by definition, this has to be a community effort. It's not a benchmark unless people keep contributing to it and respecting it. It's not a standard unless people are actually using it in their tools or at least building converters for it to the formats they're using. Again, I think this is something that really has to be looked at more at a community lens. Transparency and accessibility, there's one component that's more related to this talk, which is about fessing up about the state of systems implementations. There's been several other keynotes that have mentioned this, but I think it's an area that we need to do more work, however ugly the state of systems is. There's another component that I'm not sure is so much on the radar of PODS, which is about explaining these techniques to computational logicians outside of databases. There are people who have the techniques that we want. The trend in principles of data management is to go the other way, to really make the link to databases, use database terminology, connect really strongly to data management problems. It's natural. But of course, there's also a need to go the other way, which is to express these problems with a minimum of database terminology. That's really what I've been working on with books and lecture notes over the last few years, but I think there's a tremendous need for this in a lot of other areas. I lied. I told you that I had dozens of versions of this talk. It's more like hundreds of versions of this talk, to be honest. In one version of this talk, it really culminated with this agenda. It was all leading up to this. The structure of the talk was we had outside, inside, reasoning outside in computational logic, these challenge questions and techniques for reasoning inside, this fantastic opportunity to connect them, then this issue of infrastructure, technical and community issues leading to this agenda, this plea for a community effort. This maybe was still a little strange for a PODS keynote, but not so strange. It ended really on a positive note, but I wasn't completely satisfied with it. The reason was, reasoning, I think, has a huge untapped potential within data management. It's been there since the early days of relational data management, but it still hasn't quite achieved what it could achieve. There's a huge potential for work here, for impact here, but it's only part of the picture, of course. And if I look at this audience, probably most of the people don't work on reasoning-related problems. Maybe they'll never work on reasoning problems. And I really have an obligation that the chairs have both told me that I have to reach out to the entire Sigmod and PODS audience and give them something that might be useful from this talk, even if they don't care about this topic. And I'm going to try to do that, even if it means going even deeper into the danger zone. So I've been ragging on these problems with infrastructure for query languages, and this is a little unfair, because my experience being on VLDB, ICD, Sigmod is that there's lots of other topics within PODS and also within database systems with similar properties. They're healthy. There's a steady stream of problems, tools, experimental work, but they don't seem to really develop experimentally. There's not platforms that stick around year after year after year. There's not something that's easy to build on. There's not a transparent view of the state of the system. I want to be a little careful here with this danger zone. I'll just call it topic X. People in topic X, they've gotten used to this. It's the only thing they know, so it's an agony to write the related work, doing this diplomacy, but they think, well, it wasn't what I expected when I signed up for science, but okay, it's life. But what if they wanted to change this? What if they didn't want to accept this as normal? What could they do? Well, one thing they could do is they could give some crazy talk where they strive to get their community in topic X to recognize that there's a problem here that we as a community in topic X should deal with. That's sort of a simple first step. This is kind of an abstract version of the previous agenda. Then they could push for some concrete medium-term technical community targets. I'll unravel that from their community around X, moving topic X to have a robust experimental culture. So they could go to their community and say, let's commit, in 5 years, we're going to change this. And I want to be really clear what I'm proposing to distinguish it from other activities that you might have heard about in Sigmod or in PODS. We're not saying we're going to make it practical, because first of all, practical is a very subjective term. And also, you may not be able to make it practical in 5 years, 10 years, 15 years, who knows. Making it a robust experimental subject with a couple of platforms that people can use, an understanding of the state of the area in terms of systems, some benchmarks, some standards, that's something that a community could certainly do in 5 years if they committed to it, and they would know that they'd done it. Why do I call it a target? It's because you would track it. You could have an app for it. You have your diet app, you have your budget app, you have your exercise app, and you could have your short-term technical community targets app. This is getting at this issue of goals and mission. Database is a huge topic, changing all the time, so you can give a keynote on one topic 1 year, 5 years later, you're giving a keynote on a completely different topic. We have that flexibility. But this is putting a little bit of a check on this flexibility in topic X. You could look to institutionalize reflection and transparency around topic X. In topic X, in your conference or workshop, you have a lot of kinds of talks that are institutionalized, like Gems of PODS, celebration talks, Gems of PODS, Test of Time, Best Paper Award, Best Newcomer Award. And you could push to have a dedicated slot that's really about reflection. It's something a little different, longer period of time, and also something a little skeptical, critical. You could push to have a slot for that. Transparency, it's also a little different. It's about having an unvarnished view of the state of systems. You could push that topic X in its venues would have a specific niche for an activity around that. Okay, you're probably a much more strategic person than I am. Almost everyone is. So you probably have your own ideas about how you could make this happen. Mostly I want to encourage you to try and make this happen. Let's look at the structure of the talk now. It's got two components. One is, I'd say, technical, and it's about reasoning. There's this review of problems and techniques, this overview of these cool techniques and cool problems we have on reasoning with database queries. A look at developments outside and the opportunity to make this connection, obstacles to seizing this opportunity. And this agenda, this is the culmination. If you're really interested primarily in reasoning, this is the main takeaway I think I'd like to get from you, that we have a possibility for a nice community agenda around these problems. It's mostly about reasoning, it's mostly technical. But then there's this cultural thing that I'm into. I think it's really important. It's about potential pitfalls that can happen to a topic where there's a really broad set of problems that you can work on. It's changing every 6, 7 years. It's about pitfalls that can happen when maybe platforms don't materialize over a set of decades, or when you're in a topic that can straddle theory and practice. And it's about how to push back against these pitfalls, some ideas about this. Okay, it probably won't surprise you that I'm never completely satisfied with the talk structure I come up with. But when I look at this structure with the technical and the culture, I think it's about as good as I could do for a Sigmod PODS keynote. And I'd like to thank you for listening to it and for staying.
So thank you, Michael, for a really thought-provoking and great talk about reflection of our community. I also want to pitch a little bit. I mean, PODS has since 3 or 4 years has an experimental track, and I think Michael has really given a great, how to say, a great call to come forward to this track and to help developing it, because it's really necessary. So people are really invited to ask questions. We have time. Please step up to the microphone. Here is a nice example of he shows how to do it.
So one, kudos to you for raising this topic here at PODS Sigmod. I think it's a very important topic, and for being bold enough to try to offer some cultural analysis. But I don't think it was incisive enough. I don't think your cultural analysis was incisive enough. I don't think it uncovered, it went all the way to, you're still too diplomatic, and you're not trying to be too offensive to people. But there are cultural pathologies.
I've never been told that ever before.
No,
so.
First time ever. But there are cultural pathologies that go to our very identity as a conference. You have to go back to how PODS was founded. PODS was founded because Sigmod has another cultural pathology, which is hostility to theory. And so the people who did the theoretical research felt that they don't have a place to publish database theory paper. And in 1981, PODS was started. But because it was a reaction to the anti-theory attitude, PODS developed its own pathology, which is anti-experimental attitude. And we identify ourselves. We are theoreticians. God forbid we're going to do anything to do with any kind of an experiment. And I mean, you just have to look at PODS year after year after year after year after year. And in the early 2000s, when I decided, I was inspired, you know what, let's try to run this algorithm. Let's try to evaluate them. I was looking at a kind of reasoning or evaluation in relation to constraints. PODS resoundingly rejected the paper, saying, what the hell are you submitting experimental paper here? This is PODS. Principles meant theorems, okay? Now, in some sense, now the experimental track is some reason to address this idea, but even that, it's okay. Okay, we're going to allow some experimental track, as if somehow, you know, we have to allow for that, rather than saying, well, it's an integral part of the field. And in fact, you know, we should ask, you know, should PODS be database conference? What, Sigmod doesn't deal with principle? Why are we still creating the separation? And even though about, when did we come back to PODS and Sigmod together? Around 2000? Yeah, even there it was, okay, we'll go together, but we have to keep our own identity, God forbid. Because we didn't really fully trust the Sigmod people that they will handle theory correctly. So really we have to ask even deeper question that you're raising, which is the whole value system of doing research.
Thank you. I want to tie this in a little bit to Jan's comment about the experimental track, which I have been involved with in some form or another. This was formed around 2014, I think, and there was a feeling that it was really needed. And it was itself an experiment. Let's try this out and see what happens. But there was always an issue with it related to Moshe's comment, which is, well, what is really the goal here? And also it was a little bit of a puzzle for reviewers and also for authors saying, well, this is a theory community co-located with an applied conference. Why should it have a theory experimental track? What really distinguishes this track? And this led to several attempts at distinguishing it. The first attempt was to say, well, these should be experimental papers that validate theory or give insight to theory. And this made perfect sense. until you think about it, after which it makes no sense at all, because what kind of experiment isn't validating theory? And so there was a second attempt saying, well, these should be papers that give some idea, some new insight into theory problems that we should be solving. It has a mandate that you should be giving new theory problems based on your experiments. This is a clear distinction, which is what people were looking for, but it throws out a lot of the work I was talking about, actually most of the work I was talking about. Because, for instance, the Chase benchmarking paper, this was not about generating new theory problems. And myself, I think that getting new theory problems is not the #1 priority that this track was meant to solve. And so I want to go back and connect the experimental track a little bit to this talk and maybe to your question. If you look at Sigmod and PODS, you're a space alien, you might think that it consists of some applied people doing applied work and then some theory people proving theorems about exactly that work. So there'll be an indexing talk at Sigmod, and then there'll be some guy in the next room who's proving some theorems about indexing. And this certainly happens in Gems of Pods later today. There's a talk about join processing. And by join processing, they mean exactly what Sigmod people mean by join processing. And it's pretty clear that if you have a paper about join processing and you had an implementation about Minesweeper or Leapfrog tree join, you wouldn't need an experimental track for that. You just send it to Sigmod or ICDE. But of course, it turns out that in PODS, there's a lot of work that's nothing like that. It's more speculative. It's saying maybe we could do it like this, and this is fantastic work. Gems of Pods, I'd say Fokian's talk is more in this other category, like data exchange. People are exchanging data all the time, but not like the way they were proposing in that paper. And of course, for something like this, there's a problem of getting it into practice. This is, how do you get from something like this into practice? Here is a place where an experimental track can help you move it to have a robust experimental culture. And if you see something like that as the goal, then some things become clear. But one thing is it has nothing to do with generating theory questions. The goal is to get these things, to move this commitment, move these things to have a robust experimental culture, this topic, this topic, this topic, this topic. That's the goal. It becomes easier to evaluate papers, which I think has been a huge problem with the experimental track, diametrically opposing violent opinions about what the track should be. This gets around it, having a clear goal. But also, it's having, I think, an interesting answer to Moshe's question about what is the distinction from this track from work in Sigmod? And the answer is, well, it doesn't have to be theory. These papers shouldn't have to have theory in it. It's just that PODS has a huge need for this, so PODS started this. If we could have it joint with Sigmod, but we want to make sure that there's enough PODS people involved that it won't be taken over by Sigmod. But I think having the experimental track as a joint track, or at least getting rid of the notion that it has to be branded as really being about theory. This is, I think, at least in my view, getting these things to transition from being more speculative to having a robust experimental culture. That's what it's about. And there's a lot of communities in Sigmod that could use this too. So I think reaching out and trying to see how this experimental track could have this kind of mandate maybe would address part of your question.
Hi, Michael. I'm Xin. I'm from Pivotal Software. Great talk. Right. I have one question. On your agenda, you mentioned something called Minibase. Like Minibase to do DB-related stuff.
Yep.
And I'm wondering about what's your vision in the Minibase? What it's going to do? How people collaborate and build it together? Say, I have one concrete question. For example, I have a query optimizer.
Yeah.
Say it's open source query optimizer. How can I, say Orca, how can I prove that query optimizer is actually correct? How can I use your theory to really prove it?
Yeah, so this is a different kind of, so applications within verification are certainly another kind of challenge that I decided not to talk about. And of course, a good place I think to start on this is one of the Cosette papers where they give some examples of using some of these reasoning techniques to verify certain kinds of transformations. And I think there's been quite a number, reasonable number also I saw in either Popol and PLDI, some other kinds of uses. Of course, there's a lot of work you have to do there at closer to the database application level. And my vision was a little bit different. It was more bottom up to say, okay, here are some techniques that we can start with. We already know the basic techniques. And we have another set of applications, another set of case studies you know, from theorem proving, that we can use these same techniques on, and we can start building up, getting around some of these issues about getting benchmarks from database systems, which has a lot of other issues involved. So we could start with this sort of bottom-up approach and then go to these verification problems. This was my concrete vision for how this would be built up.
Wonderful. Thanks.
So good morning. I'm a researcher on the more practical field, but I've noticed that recently the most ideal thing is to tackle some theoretical aspects and problems to solve practical problems, actually. So, but while doing that, I noticed some problems. Like, for example, in some cases, some ideas could, for example, use some approaches used in type theory within programming languages, and that could be using them on data analysis, for example.
Yeah.
But the problem is sometimes it's very difficult to deliver the message to the practical audience. Because actually I have an idea, for example, but in order to explain that that solution could be beneficial, there is a gap, for example, in some cases, in order to say that could be something, but I have to convince someone, and that is some problem. So is there a way to deliver the message in a very straightforward way? And the second thing I was thinking of is, for example, in the data mining group, there are two different approaches, for example. Some people like to do clustering, and more theoretical guys, for example, rely more on topological data analysis. But the problem is that, for example, if you want to do topological data analysis for sure, then the problem sometimes is NP complete. While on the other hand, we want to deliver the algorithm in a very quick way because it's unsatisfiable for huge data, and so we have to approximate the problem. So with the topological data analysis, I have the assurance that the approach is correct, but so is always the approximation the solution, or it is not? So.
Okay, so let me just the first part, which I think I understood about, getting them. This was about getting the message, this gap. How do you get these things? I think interactive theorem proving is a kind of interesting example because this stuff is very complicated. I mean, I followed this in the 90s. You needed like 4 PhDs to work on this, and then after 4 PhDs and a lot of hacking, you could get up and running with this stuff and then maybe prove some fundamental result that was in algebra, that was a total yawner. And at least I think one of the ways they've handled this is they've really built up their platforms. So even if people can't understand that so much, in the case of Lean, it's really hard to understand the theory behind it, but people can just get going with the tutorials and just start doing it. And I think what I found is, at least in using Lean, I don't know what the experience in Coke, is after you start using it, after you can really just get going hands-on, then you begin to sort of by osmosis understand, what it's about. And I think this sort of bottom-up approach, I think this is a little bit more the style in Cosette, as far as I understand it, is like, let's get this up and running. People can begin to experiment and see what they can do with it, get some tutorials up and saying, well, here's what you can do with it. Once we have a big enough user base, of course, people will begin to help themselves. It's very hard for tools that don't have a large user base. People are scared of investing the time in starting to use some tool that they don't know is going to be around very long. This is the best answer I can give to that problem. The second part was about efficiency. And I mean, I should mention that these approaches for reduction to theorem proving, they have some efficiency concerns, of course. And I mean, first of all, I think an advantage of doing this in the framework of logic is it should be easier to prove that this approximation is, say, sound or conservative in some sense, so better than the kinds of heuristics that you might use without this kind of foundation. And so, of course, it requires some expertise to prove these approximation results. But having this foundation, if you're concerned about this, then it's easier to do it with these kinds of tools than to use with some other tools.
Okay, thank you.
Well, thanks, Michael, for a very entertaining talk. So my question is about the cultural points, and particularly because you mentioned cultural problems within the community. But I believe that there are also cultural problems that come from the outside, right? Some people would agree in that if this didn't happen so far, it's because nobody is motivated enough to make it happen, right? So So you know how hard it is to really build a good reference implementation, right? And at the same time, you have to be publishing and you have to meet some deadlines from the outside world. So you also have to fight cultural problems that come from a much bigger structure. So you also have to fight that. So basically, my question is, what's your perspective on that as well?
So I think this is a great question, but it also fits in this discussion of experimental track, and maybe a demo track. I think is something that could, Sigmod I think has in some sense looked at this problem and said, well, we have to give something for people who are doing, we really appreciate this result, this kind of work, and we have to give some sort of carrot for this. And I think this is one way to think of the experimental track. I think we've sort of muddied the waters by saying that it should have also lots of theory in it, or in some cases, some reviewers think it should have lots of theory in it. But I think this is part of the point of this track, these tracks is, this is one thing a community can do is to start giving recognition to these kinds of activities. I think there's probably other kinds of activities. Like I said, I'm not the general chair, and so I don't know. But if you take this as the goal, you can begin to think as the community, what can we do as a community to start giving people motivation to spend this time? Because you're right, I mean, convincing postdocs in this environment to say you should be slaving over making something usable, I mean, this is very difficult.
Hi, my name's Julian Hyde. I work on Apache Calcite.
And what?
I work on Apache Calcite.
Yeah,
it's,
sure.
It's a project of the Apache Software Foundation. We've been talking to Arvin. So Calcite is, for people who are not familiar, it's not a query optimizer, but it's a framework for building query optimizers and that kind of stuff, the stuff you need to build a database, but it endeavors not to be a database, so that you can kind of plug it into your own system that you're building. At Apache, you mentioned the word community a lot, and at the Apache Software Foundation we have this mantra, which is community over code. Build a community and the code will look after itself. And I would posit that focusing on community is the solution to the problem that you are posing. And you need to think about not just the community of people that are writing this software, but the people that are using it. Because if you have a simplification algorithm, the people that are writing it are not the same people as the people that are using it. And I would definitely invite people who are interested in this to come into the Apache Calcite community. Because this stuff is being used, there's probably like 25 databases that are used by Calcite, and we've written this kind of stuff like view rewrites and expression simplification and constraints and so forth. We've written it, but we're amateurs because we're in industry mostly, and we don't have the expertise to even recognize that this is a SAP problem. So if somehow we can connect, Calcite it's not a community that's going to evaporate when, in 2 years' time when all the postdocs move on to something else. It's a sustainable community, and it could be a good home for this kind of effort.
Yeah, I think that's a fantastic point. I mean, I see 2 points in what Julian, you said is your name? In Julian's talk. One is just Calcite as a, I was interested in it mostly as a front end. You have this big problem of just dealing with SQL, and if you want to get it down to logic, I mean, in Calcite, they have their own version of relational algebra that you can compile SQL into. Just, having a set of standard tools for this first part is so nice. I haven't looked so much at the rest of the framework, so just using these concrete tools, this makes it also very timely. Now, the second part of yours is that maybe people in Calcite have some insight into how to build community. And I haven't thought about this, but this is a great comment. Other people who have done this successfully, and also as a target for this, I think you meant for this kind of software. So I think would be great to get together and to look at what kind of insight you have from being part of Calcite.
Yeah, as Apache folks, we're happy to teach you. I think this is our big contribution to the world is knowing how to build software communities. So please feel free. And I'm giving a talk tomorrow about Calcite, so please come along.
Hi, Michael. Thank you. Great talk. So as I listened to your talk, I reflected on my various failed attempts to motivate a group of people to do this. And as you think about motivation, people who study motivation, a big part of it is giving the people a why.
A what?
A why.
Yeah.
Why do this? And as I reflect on this, I think there are examples that I can think of, like maybe mechanizing Peter Baylis's analysis on transactions so that you can get much faster performance on TPCC benchmarks, or picking examples, analytic examples that are more machine learning driven and AI driven, that gives you, where this kind of analytic, this kind of reasoning can give you much better performance or make certain problems tractable and so on. So have you thought about investing in giving people the why?
Well, I just want to start by saying, right now the situation is it's up to individual PIs to do this motivation. And each time I think the people are naturally wondering, well, will anyone appreciate this once we do it? And I think this is, so really I want to duck this question in a bit and say, well, if the answer is really no, that if we go into this work and we put out this platform, nobody's going to use it. We do this benchmarking paper in the end, people are just going to ignore it. Then the answer is to why is there isn't any why. So I think really it does have to start with the community.
Thank you.
Okay, so let's thank everybody for this nice discussion, and let's thank Michael for his excellent keynote.